If you stopped working out, your muscles didn't disappear. They left a hidden blueprint behind. This is the thing that stops people from ever restarting. Take Marcus. He trained seriously for 2 years, built real strength, and then a new job and a cross-country move ate his schedule completely. 8 months went by without a single session. No gym nearby he trusted, boxes to unpack, a new commute eating the hour he used to train in. When he finally looked at booking a gym membership again, the thought that stopped him wasn't, "I don't have time." It was, "There's no point. I'll basically be starting from zero, so why bother?" Most people assume muscle works like a bank account. You make deposits, you stop, the balance drains to zero, and you're back where you began, no better off than someone who never trained at all. That assumption is wrong, and it's costing people like Marcus months of progress they didn't actually have to re-earn. And in some cases, it cost them the restart entirely, because starting completely over feels too discouraging to bother with. Here's what's actually happening at the cellular level, and it turns out there are 2 separate systems doing this, not just one. The first is structural. When you build muscle, your existing muscle fibers recruit new nuclei, the control centers inside each cell, to help manage the increased size. Normally, a muscle cell has a fixed number of nuclei for its size, but training adds extra ones, and the cell doesn't have an easy mechanism to remove them afterward. Here's the critical part. When someone like Marcus stops training and the muscle shrinks back down, those extra nuclei don't disappear along with it. They stick around, dormant, for far longer than the muscle tissue itself lasts. For years, this was mostly shown in animal studies. Mice can be tracked far more invasively than people, which left real uncertainty about whether the same thing happened in humans. That changed with a 2024 study in the Journal of Physiology, which directly confirmed retained myonuclei and long-term transcriptional changes in human muscle after strength training, not just in mice. So the extra nuclei stick around idea isn't a theory borrowed from lab rodents anymore. It's now been shown in people, but here's the part almost nobody covers. There's a second, completely independent memory system, and it works at the level of your DNA itself. A landmark 2018 study tracked a group of people through an initial training block, months of detraining, and then a retraining block, and looked specifically at DNA methylation. Essentially, chemical tags attached to DNA that turn specific genes up or down without changing the underlying genetic code. After the first training block, a cluster of muscle growth-related genes got switched into a more turned-on, hypermethylated state. Several of these genes are directly involved in building the protein synthesis machinery itself, the ribosomal proteins and regulatory enzymes your cells use to actually construct new muscle tissue, not just generic background genes. Then, during detraining, muscle mass shrank back down to baseline, exactly like the bank account model would predict. But those same genes stayed in their turned-on chemical state the entire time, essentially unaffected by the loss of muscle around them. When the same people retrained later, those already primed genes responded even more strongly than they had the very first time. Follow-up work since then has found similar epigenetic retention after other types of training too, including high-intensity interval work, suggesting this isn't a one-off finding specific to one study design or one type of exercise. There's also an important dose-dependent piece to this. The size of the cushion you're left with, both the extra nuclei and the extent of the gene tagging, appears to scale with how much muscle you built and how long you trained for in the first place. Someone who trained seriously for 2 years, like Marcus, banks a bigger cushion than someone who trained hard for 8 weeks. That doesn't mean short training blocks leave you with nothing. Even relatively brief hypertrophy has been shown to add nuclei that outlast it. But the effect compounds the longer your training history runs. So for someone like Marcus, 8 months out of the gym, 2 things were happening the entire time he wasn't training. The extra nuclei his muscle built during those first 2 years were sitting dormant, unused but intact, and the genetic switches those 2 years flipped on were still sitting in their on position. The muscle looked like it was gone. Twice over, at 2 completely different biological levels, the infrastructure that built it in the first place was still sitting there, waiting. So what does this actually mean for you? First, regained muscle comes back faster than muscle built for the first time. This isn't motivational talk. It's a measurable effect. The extra nuclei mean the cell doesn't have to build new management infrastructure from scratch, and the pre-tagged genes mean the biochemical on switch is already flipped rather than needing to be found and thrown for the first time. Studies on detraining and retraining consistently show this faster second-time pattern. And it's exactly what let Marcus get back to his old numbers in a fraction of the time it took to reach them originally. Second, this is a big part of why newbie gains only really happen once, but returning gains can happen repeatedly. progress your loads faster than a true beginner would, because your body isn't learning the movement and the adaptation from zero. It's reactivating a system that already knows how to do this, at both the structural and the genetic level. Fifth, and this is the one thing that trips people up when they come back too fast. Your muscle's memory doesn't mean your tendons and connective tissue have the same memory. Tendon and ligament adaptation runs on a slower, separate timeline that isn't covered by either of the two mechanisms we just talked about. This is exactly why the smart move is to load the muscle aggressively but let the joints catch up over the first couple of weeks, rather than assuming that because the muscle is ready, everything else is too. Now here's the part almost nobody talks about. There's actually a specific window where this muscle memory effect is strongest, and it's not what most people assume. The retained nuclei don't last forever, but the research suggests the window is measured in years, not months, for many people, especially if the muscle was held for a meaningful period before detraining the way Marcus had trained consistently for 2 full years before his break. That means someone getting back into training after 2 or 3 years off still very likely retains a real advantage over someone starting completely fresh, even if it doesn't feel that way in week 1 staring at an empty bar. And the epigenetic side of this may be even more durable. In the 2018 study, participants trained then went through a genuine detraining period long enough for muscle mass to fully return to its untrained baseline, and the DNA methylation changes were still detectable at that point, with no sign of decay back toward a true untrained state. When they retrained, the same genes didn't just turn back on, they turned on more strongly as you'd expect from a system that had been primed rather than reset. This is part of why researchers now think of muscle memory as at least 2 overlapping systems working in parallel, rather than one single mechanism that either holds or fails. If one system fades faster in a given person, the other is very likely still doing its job in the background. The discouraging feeling of "I lost everything," the exact feeling that almost kept Marcus from ever rebooking that gym membership, is a perception problem, not a biology problem. Your strength dropped. Your muscle memory didn't. And now there are 2 independent, separately confirmed reasons why. So to bring it back, muscle loss from time off is real, but it's surface level. The cellular infrastructure and the genetic switches that took the longest to build in the first place are the parts that stick around, which is exactly why coming back is faster than starting. Whether your break looked like Marcus's 8 months, a shorter injury layoff, or something considerably longer. If you want to know exactly how fast faster actually is, how many weeks it typically takes to reclaim lost muscle versus building it new, how the timeline changes depending on how long your break was, and what the single smallest amount of training is that can prevent most of the loss in the first place. That's the next video.